Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's problem, we'll be working on merge sorted array. The problem states that we are given two sorted arrays nums1 and nums2 and also two integers m and n representing the number of valid elements in the given arrays. So our task is to merge nums1 and nums2 so that our task is to merge nums2 into nums1 so that nums1 becomes a single sorted array in place. So for the brute force approach, the idea is we will create a new array and we will copy all the elements from nums1 and then we'll copy all the elements from nums2 and we'll sort the new array. And then we will copy everything back into nums1. So the code for that goes like this. Let's initialize a new array. Let's say temp of it would be the size of m and n plus n, and let's take an index variable starting at 0 I less than m. Now let's put it in temporary variable or temporary array nums1 of I. So now in the temp we'll be having all the elements of nums1. Now in the next for loop, let's start it from j0 to jn and j++. Let's put nums2 of j. Now in the temporary variable we have all the elements of nums1 and nums2. Now let's sort it. Is dot sort temp. Now we need to return nums1 itself, like we are not actually returning it but we need to put the sorted elements in num1. So for that we need one more for loop. I less than, it would be m plus n this time, and I plus plus nums1 of, we are putting it in nums1 of I from temp. Okay, let's run the code. Well, this works, but this is not optimal because we are using multiple for loops and we are also using an extra array, but we have to do it in place. So for that we need to think of an optimized approach wherein since nums1 already have extra space at the end, we can merge from back to avoid overwriting elements. And the strategy is we would need pointer I where it starts from the last valid element in nums1 and pointer j which is at last element in the nums2 and pointer k which is the last index of nums1. So now we will compare and place the largest element at position k. So for that okay, let's start taking int I as m minus 1 which is the last element in nums1 and int j as n minus 1 which is the last element in nums2 and int k which is the last index position. So it would be m plus n minus 1. Now let's iterate until I is greater than or equals to 0 and j is also greater than or equals to 0. Now we will check if nums1 of I is greater than nums2 of j. If it is, then we will put it in nums1 at k position. We will decrement it later. We'll put nums1 and we'll decrement this. Okay, now if nums1 of I is less than nums1 of 2, it will come to the else block, and there we will put nums1 of k equals to, now we'll put nums2 of j and we'll decrement it. Now we'll be having all the sorted elements, but in case if nums2 still has elements, because they did not guarantee that the size of two arrays would be equal. In case if nums2 still has elements where j is still greater than or equals to 0, then we will put the remaining elements in it at the index position nums2 of j minus minus. Okay, let's run it. Let's submit it. Wow, it is working. So for example, if you consider this nums1 has 1 2 3 0 0 0 and nums2 has 2 5 and 6. Initially the I pointer is at 3, which is at index 2, and j pointer is at 6, which is at index 2. Now initially we'll compare this 3 and this 6. Since 3 is less than 6, it will enter into else block and we would put nums2 element in it, and then we will compare okay, then we will put nums2 element, which is 6 here, and then we will compare 3 and this 3 and this 5. So we will put 5 at the end, and then we will compare 3 and 2, 3 and 2, and then we will compare 2 and 2, and then we'll compare 1 and 2, and at the end we will have the sorted array as 1 2 2 3 5 6. So the time complexity for this would be O of m plus n, and the space complexity would be linear because we did not use any extra space. So here the brute force is easy, but it is not very efficient. So the optimized solution uses 2 pointers from the end. That is it. So yeah, in the next video we'll continue with a same pattern based approach. Thanks for watching, and I'll see you in the next problem.